Okay, good morning, everyone. Today we're going to study portfolio optimization and the efficient frontier using Excel. I provided you with a worksheet. Okay, there are some notes there. Okay, we're going to use them later on. In particular, the formula. Okay, and so let's download stock prices from Yahoo Finance. Okay, so let's identify first what will be our start date. Let me capitalize this. Start date and the end date. Logging again. Okay. So let's take maybe 2 months. Let's say 4 months, because there are no trading days on weekends. So 120 days, maybe that will be diminished. Sir, I think your screen is not moving. Okay, sorry. I'll resume. Sorry about that. Okay. All right. So I just placed here start date and end date. And let's get it, let's say 120 days before. So we can use the today function, today. This is equal to today. Okay. It will give us a date today minus 120. So let's do, oops. Day minus 120. What's happening? Let me close this. Oops. Wait. Okay. So 120 days ago, that's 11/22/2024, and the end date is today. Okay, so we'll get stock prices from 120 days ago, okay, up to today. So if you recall, it's best for us to give a name to our constants. So here, Control Shift F3 for some of you, Control Shift Function F3. Okay, so the names are on the left column. Okay, so if we check this is start date and end date. Okay, so that we don't have to link to this cell. Okay. So let's use what stocks are we going to use? Let's use Apple, Google, and Apple. Let's write the ticker symbol here, Apple, and then Google, and then NVIDIA. Okay, the graphic. What do you call it? Okay, so we're going to write here is equal to stock history, and this is our stock. Okay, comma, start date STAR, the start date there, comma, end. Okay, so if we just input these two, then it will insert a date column. Okay, Control Enter. Okay, let's wait for it to load. Taking long in my case. There. Okay, class, were you able to get it? Kindly chat, please. If you were able to download the stock price of Apple from from November 22, 2024 up to today, March 22. Of course, March 22 will not be reflected because it's a Saturday and there's no trading on a Saturday. Okay, how about the others, please? Okay, good. Let's wait for your classmates. Okay, who else? Nix, were you able to download? Okay, good. Thank you. All right. So now we can also download uh, Google. Okay, but we will use a different, we will adjust the code, the function stock history because we don't want the date to be repeated. So our stock will be Google, comma, start date also, start date, comma, end date. Okay, and then we'll type 3 commas. Okay, 3 commas so that the date will not be inputted and also the others, and then just one. We'll use a closing prices. The default here was closing price. Okay, so we'll just follow that closing price. Then enter, control enter. And then we can just copy this to the right. Okay, so let's just use 3 stocks, okay, for our discussion. But for your case, you'll have to use 10 stocks, Philippine stocks. Okay, and then let's format this, Control Shift down arrow, Control 1, and let's remove the 2 decimal place. Let's remove the currency. Okay. All right. Are you able to follow, class? Please pardon me if I keep on asking questions if you're able to follow because we don't want any one of you to be lagging behind. Okay, so please tell me if you have questions. Okay, good. Thank you. All right, good. Okay, so we now compute for the log returns because in it's better if we use log returns as compared to simple or discrete returns. So let's copy this. Let's copy this Control C, and I'll move it. Where should I move it? Maybe here. Okay, here. I'll occupy this row because we will be losing one observation, right? Because when we compute for the returns, okay, it's you're getting the ratio, log ln ratio, ln between the current and the previous value. Okay, so let's do this. This is equal to ln natural logarithm of date quote unquote today divided by the date, the price yesterday. Control enter, and we have this. Okay, and maybe we can make it percentages. 1, 2, 3, before decimal places, and then copy down. There you go. Okay, and I'll just center this. Let's just fix this, and I'll for easier for us to easily just put a fill to it, and let's give it a name. So this is daily, sorry, daily log returns. Okay, then let's Control 1. I'm going to wrap or merge. Okay, center it. Okay. All right. So that it looks a bit a bit good. Formula, okay, formula. Okay, so the formula is, oops, sorry. What's happening to my computer? Here, function F2, there. ln of B7 over B6. Natural logarithm. Okay, that's your log returns, that's your continuous returns. If you're using discrete returns, it's the the price at time t divided by that price at time t, t minus 1, and then minus 1. Okay, so just for discussion, okay, if I'm going to use simple returns or discrete returns, it's this one divided by the previous value minus 1. Okay, so you can see there's a difference between discrete returns and log returns, continuous returns. Okay, all right. And then uh, let's get the excess returns here. I'll copy this, Control C, Control V, and then copy this, Control C, Control V. I'll name this as excess returns. Daily excess returns. Okay, I'll give it a different color here. And excess returns means you're subtracting your daily returns from a certain benchmark. Usually, the benchmark, let me write here, the benchmark can be your risk-free rate, okay, which can be represented by the 10-year, 10-year, 10-year US Treasury bill, okay? Okay, and there are several sources for this. Let's just put this. Okay, so for example, here I'll give you this Control C, and then in the chat box, bagal. Okay, you may take note of that. There are other sources of course also. So this is Treasury TMU. This is the ticker symbol. Okay, it's 4.257. I'll also copy this, see, and put it here. So slow. Okay. All right, but we're not going to use that. We may use another metric that we use for excess returns is the average. Okay, so let's get the average of our expected returns, E sub r, is the average of our stocks. Let's copy this here. Control C. Hold the line, class. Okay. I'll pause for a while. Okay, sandali lang, class. Okay, so let's compute for the expected returns or the average returns. So for Apple, it will be equal to the average of our daily returns. Control Shift down arrow, Control backspace, close parenthesis, Control Enter, and then we copy this to the right. Okay, so that's our average returns for this period. We should, and usually I would put borders, Control 1. Let me just put borders and fix this. Okay. Mm. Every time I would go to another cell, it takes time. Okay, so let's get also the standard deviation is equal to standard SDev. Dot P is for the S STDev dot P is for population, but since this is not population, we can use STDev dot S, or the old one is STDev. This is the old function. So I'll just use STDev dot S sample. So for Apple, control shift down arrow, control backspace, close parenthesis, control enter. Okay, and let me just uh, standard deviation, and of course your variance, just standard deviation squared. Control enter. Okay, so that's our standard deviation. And then our Sharpe ratio is, the modified Sharpe ratio is simply your expected returns divided by your variance. And our N, let's just count this count of how many observations do we have of the returns? 78 observations. Okay, let me pause for a while and ask your feedback, your comments so far, if you're able to follow. Ay, wait, what did I do? What did I use? Sorry. Ah, yeah, sorry. Yeah, it's the variance. Thank you. So it's the return over the variance. That's a Sharpe ratio. Okay, sorry, I got confused. So I would usually start with variance and then standard deviation. But in this case, I started with standard deviation. Okay, you're right. So it's risk per unit, it's return per unit risk. Okay, good. Thank you so much for pointing that out. All right, so hope everybody's okay. Okay, now we can compute for our daily excess returns, which is our daily returns minus our expected returns or our average. Okay, and then we fix this function F4. Fix the row because we're going to copy this formula to the right and down. Okay, to the right here. Not moving. Sorry. Enter muna bago i-move. Sorry. Okay. And then click. Okay, so we have now our excess returns. I'm going to color code this. Okay, so that I can easily see where are my log returns and where are my excess returns. Okay, so there are some measures here that we're going to use. For example, when we compute for the variance, covariance, and the correlation, standard, and also for the portfolio risk and returns. So we're going to use the standard deviation, this matrix. So I'm going to highlight this and give this a name. Okay, I'll call it ST dev, standard deviation, maybe STD. Enter. All right, so we now have a name for our standard deviation. Variance we're not going to need. Okay. This one, the daily excess returns, Control Shift Enter. We're going to need this, the whole of this. My Excel is Control Shift down arrow, and then I'll name it excess returns. I'll just use X ret. Okay, you may use the same name class so that we have the same named ranges. Okay, what are the names that we have used? End date, start date, standard deviation, and X ret. All right. So now we're going to compute for our variance covariance. So let's copy Apple, Google, and NVIDIA here. Control C, and then here, transpose there. So let's first start with the long formula, Control C. If you're not going to use matrix algebra, then this can be really very, very difficult. Control V. Okay, so let me just illustrate to you, class. For example, if you're going to get the the variance or the covariance, okay? Variance if you're getting the relationship between an asset, covariance would be two different assets. But we can make use of the covariance class, covariance formula. Covariance. So this is apple with apple. So what's the covariance of apple with apple? So it will be apple, this one, Control Shift down arrow. Okay. And then we can fix this function F4 because we're going to get the covariance of Apple with Apple and then Apple with Google, comma, this time with Google. Control Shift down arrow, Control backspace. So this is the covariance of Apple with Google. Okay. And I'm fixing Apple so that I can copy this formula to the right. Control Enter. And I'll make it into percentage Apple with Apple. What happened? Variance function F2. Wait. Covariance of Apple with Google. Covariance controls enter. H7 I7 0.0126. Why? Covariance of okay. My mistake. It's Apple with Apple class, sorry. Why? I was wondering why it's not the same as this figure. So it's apple with apple. Okay, control. Oops, I have an extra parenthesis. Control enter. Okay, 0.268, practically the same as this one. Okay, if I make this into a number also. Oops, there. Okay, the same, right? If I copy this to the right, there, 0.0013. What's this? Google variance. Again, function H and I. Of course, it's covariance. It's not variance, sorry, class. Okay, so then we go here, class, is equal to covariance S. Okay, this time Google. Okay, but I'll start first with Apple. Or so it's Google with Apple, and then Google. Mm. And I'm going to fix I because we're getting the covariance of function F4. There you go. Okay, control enter, and I copy this to the right. 0004 here, class. It's the same variance of Google. So Google with Google. Okay. Okay. And lastly, class, NVIDIA, it's equal to covariance. Covariance of, I'll start again with Apple, Control Shift down arrow, Control backspace, comma, and then I'll go to NVIDIA, Control Shift down arrow, Control backspace, and then I'm going to fix that. Function F4, close, Control enter. Okay, and then let's make it the number. Okay, copy to the right. The variance is 00152. Okay. So these are your variances. This one, and this one. Okay. And they all agree with our variance here. Okay. All right. Let me pause for a while and kindly requesting for you to chat in the chat box if you're all good. Good. Okay. I'll give you time. Take your time. We manually computed for the covariance, okay? AKA variance. Covariance of apple with apple is just the same as the variance of apple. So let's wait for the others to finish. Okay, good. Wait for... Sino pa ba yung wala? About Johan? Johan, are you okay? Johan, Sophia might not be able to reply. Johan, are you okay? Okay, baka nag-step out si Johan. No? Okay, so this process is quite tedious, especially if you have, let's say you have a 10 by 10, 10 assets, okay, and then you're going to have to write a formula for, you cannot write a formula for one and then for all, okay? All right, so dapat class per asset yan pag ganun. But that's very time consuming, and there's a better way. That's why I wrote this formula. Okay, so using matrix, we say that the variance, okay, the variance covariance is actually equal to so here again is my logging Excel. The sigma ij, okay, this is a symbol for variance. Okay, take note there are two subscripts here, I and j, so you're getting the variance between covariance of I and j. So this is not standard deviation. When you write standard deviation, you only have, if you're writing standard deviation, write sigma sub I, okay? So this is standard deviation. Sigma sub ij is variance. It's a covariance of I with j, or sigma ii, it's the variance, covariance of I with I, which is the variance. Okay, so just take note of this. This is sigma ij. This is covariance, and the formula is the transpose of our X matrix multiplied by multiplied by X divided by the number of observations minus one. Minus one because this we're dealing with a sample. Okay, so how do we do that? This is just matrix algebra in Excel. It's really very easy. Okay, so you have to highlight first your matrix before you start working on your formula. So this is equal to, maybe I should increase the size so you can see better. You have to highlight first. Okay, let me put a field there, is equal to. So you are actually doing matrix multiplication. What's our XRET? This is our XRET, our daily excess returns. This one, their class, XRET. Okay, remember we gave a name to it. That's our excess returns. Okay, and to compute for the variance covariance, which is this one, we can easily compute for it. Highlight your your 3 by 3 matrix because this will generate a 3 by 3. There are three assets, a by 3, so it will generate a 3 by 3 matrix. It's equal to, so we're multiplying this, mmult. So the function in Excel is mmult, matrix multiplication. So what are we multiplying? We're multiplying the transpose of X with itself. Okay, so we have to use the transpose function. We have to transpose, what's our X? X is XRET. There. That's why we gave it a name, so that it will be easier Okay? So transpose of X ret, close natin. Let's close the transpose. And then comma. So we're multiplying it with X ret. X ret also. X ret. There. And then close it. All right. So that will be your M mult. X M mult times M mult of the transpose of X ret with X ret. And then we have to, okay, sorry. Let's give this a name. Did we give this a name already? Not yet. Okay. Let's give this a name. N. I'll call it N. Small n. Small n. Okay. All right. So this has a name. 78. Sorry. What happened? Wrong. Okay. Control. Function. Shift F3. My mistake. Control Shift. Control function F3. I'm going to delete N first. Okay. I'm going to edit this. And N refers to not L, only M. Only M10. I'll just remove this one. I don't know if it's my mouse or it's this one, 78. Okay, M10. So that's my N, 78 there. I'll close this. So let's highlight again our matrix, and it's equal to, so we're multiplying these two matrices, M mult. That's matrix multiplication, M mult. And then what are we multiplying? The transpose of X ret with X ret. So I have to put here transpose of X ret. Okay, we named this object X ret. Close the transpose and then with X ret again. Okay. And then divide it by, okay, divided by, we have N, right? N, N. There. Small n minus 1. Okay, so take a look at that formula. So it's a lot easier, class, compared to the manual way of computing for your uh, variance covariance. So since this is a matrix, when you should not press enter. What you should do is press Control Shift Enter. In Mac, Command Option Enter, I think. Command Option Enter. In Windows, Control Shift Enter. Okay, so there you go. Okay, let's put them as a number. Okay, so you can see here the variance 0.027, 0.0041, and 0.0152. So this is the variance of apple with apple. Google, or covariance of apple with apple, is its variance. Google with Google, NVIDIA by NVIDIA, exactly the same. Okay? Okay, once again, class, let me ask you if you are able to follow. Okay, thank you, Nix. And the others, please. Okay, thank you. iMac alternative. So for iMac class, anybody using here iMac? Kasi in Windows, it's Control Shift Enter. You have to press that. For iMac, I think it's Command Option Enter ba? Is that correct, class? What's yes, Jishan? Is it the what you'll need to press? Command Option Enter for Mac? Okay, thank you. Okay, so we have now the variance covariance. Okay, let's give this a name. Let's give this matrix a name. Let's call it, put it in the name box here, var cover, because we're going to refer to this later on many times. Var cover, enter. Okay, so this is now var cover. All right. Okay, and as an exercise, we can compute for the correlation also. Let me copy this, Controls C, and then here, Control V. Okay, again, Control C, Control V, and I'll delete this. Okay, so if you need to compute for the correlation, this is the formula for it. Rho, this is your correlation, is equal to the square root of, this is your variance covariance. So you'll need the variance covariance divided by this standard deviation of the transpose of the standard deviation times the standard deviation. So that's a matrix multiplication. Okay, so let's highlight again our resultant matrix. So it's equal to, you have here the square root. Square root. Square root of, this is your variance covariance. So I'm going to type var cover here. Okay. So var cover divided by, and here you have matrix multiplication. I'm going to put here m mult. Okay. Should I m mult? M mult of what? So we're multiplying standard deviation, the transpose of the standard deviation multiplied by the standard deviation. So I'm going to get the transpose first. Transpose of your, we already created this stdev, right? This one. So I'm going to use that here. STD, okay, standard deviation. So I'm going to close transpose, okay, transpose of standard deviation. And then in the front, you have M mult. So we're going to matrix multiply this transpose of the standard deviation with standard deviation. Okay, and then close close transpose. Oops, no. How many? 1, 2, 3. 1, 2. Okay, there. Okay, and as usual, class, this is a matrix multiplication operations or process. Then we have to press Control Shift Enter. Control Shift Enter. Okay, and then you can see here that the we're correct because the correlation between Apple and Apple is of course 1, Google and Google is 1, NVIDIA with NVIDIA is 1. So we're on the right direction. Okay, the correlation. And what's the purpose of correlation? You can see here that, for example, Google and Apple are quite um, highly correlated. We don't want assets to be highly correlated in your portfolio. Okay, we want the assets to be not not correlated. Okay. All right. So let's now go to our portfolios. So far, what we have done is we have computed for the daily log returns. We have computed also for the daily excess returns. And we computed also for the variance covariance and the correlation. Okay, so now let's determine, class, what will be our our portfolio. Okay, so here we write the weights. Okay, so let's first write, we need the returns. Let's just copy this. Control C. We need the expected returns. Maybe we'll put it here. We need also the risk. Okay, and uh, oops. Okay, expected return. Weights, we also need the standard deviation, insert, symbols, insert symbols, sigma here, sigma of our portfolio, close, sigma P. Okay. And then let's also copy the Sharpe ratio here. Sorry, class, my computer is acting up, taking so long. Sorry for the editing. Okay. Let's put this down and put the asset names here. Let me put this in with the fill color, light blue there. Okay. Okay, so since this is equally weighted, the weights of each of the assets should be 1/3. And the sum of this alt equal to, the sum should be 100%. Okay, so our first asset is equally weighted. So we have 1/3, 1/3, 1/3. So what will be our expected return? Okay, our returns for the assets is this one, right? Pangit pa na yung negative, ano? Average returns natin. Okay, anyway, so our expected returns, if it's equally weighted, is of course, you just multiply each of the weight by the individual returns. The average return of Apple is this one. Multiply that by 33.33%. So this will be equal to, you can use matrix algebra, okay? You can use matrix algebra, so this will be M mult happened here. M mult of the weight matrix. So this is 1/3, or we can transpose this to 3/1 and then 1/3. Okay, let's transpose this. Transpose of 1/3, it will become 3/1 and multiply it to here, our expected returns. Now we're going to copy this formula so that I'm going to fix function F4. I'm going to fix the expected returns. Okay? All right. And two parentheses. And since this is a matrix, control, even if it's only one cell, control shift enter. Happened. M6 to 06. Nag-error siya? Why? So this is 1/3. It will become 3/1. So 3/1 by 1/3. 3/1. Oh, wrong. So dapat 1/3 by 3/1. Okay. So I'm wrong yung formula ko. Sorry, class. So sorry, M mult ng weight matrix. So this is 1/3. And then we're going to multiply it to the transpose. Okay. Transpose of our returns. And I'm going to fix this function F4. Okay, there you go. So you're multiplying the weights by the returns. Okay. So it's just like weight 1 times return 1, weight 2 times return 2, weight 3 times return 3. So this is the weighted average of your returns. Okay, so control shift enter because I used a matrix here. Okay, so this is the Let me put this in percentage. All right, so this is the expected return if this if the stock is 0.1/3 each. Okay, and then our sigma class. Okay, it's not here, but the the variance class of a okay, I should have written it here. Square root of your weight matrix. So let me write that formula. Weight matrix and then transpose and then let me use the sigma, the variance covariance. Insert and then weight matrix. Weight matrix, control 1. All right, so this class, so it's the square root of the weight transpose. Then you have your variance covariance times your weight matrix. So that's the formula class for the risk of a portfolio. So let's do that. It's equal to, so we have square root of, so we're matrix multiplying the transpose and the weight transpose and the variance covariance. The sigma here class is your variance covariance. Okay, so we have to do m mult of, okay, let me first move this so that I can see it. Here, it's equal to square root. And then square root of m mult of this one class. M mult, we're matrix multiplying what? The transpose of weight. So transpose of your weight, okay, with what? So we're multiplying it with the transpose of our matrix with the variance covariance. There, var covar. So that takes care class of the transpose and the variance covariance. Okay, so I'll close this. And then I'll matrix multiply it again. So I'll have another m mult with, this time with m mult with, what's this class? That's your weight. Close. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2. Okay. All right. Then, since this is a matrix formula, Control Shift Enter. Oops. Y value. M mult transpose of our weight matrix is, let me see. Our weight matrix our weight matrix has a dimension of 1 by 3. So if we transpose that, it will become 3 by 1. And we're pre-multiplying this. Okay, and then we're multiplying it with variance covariance. This is wrong. So it should be, okay. So weight matrix is 1 by 3. Variance covariance is 3 by 3. So this should be the regular weight and then multiplied by the transpose. Let's check. Okay. Okay. 3 and 3, 1 by 1. Okay, so the resultant matrix is 1 by 1. 1 by 1. And then this is W transpose. Wait, sorry. 1 by 3. And then this is 3 by 3, sorry. 3 by 3. Our variance covariance matrix is 3 by 3. So the resultant matrix here is 1 by 3. And therefore, our weight matrix is 1 by 3. But if you transpose it, this becomes 3 by 1. This becomes 3 by 1 because you're transposing it. The original is 1 by 3. Okay? But we transposed it so that it becomes multiplicable. Okay, and then 1 by 1. Okay, so it should be weight. So my formula here is wrong. This will be right, class, if the weight matrix was Control Shift Enter. Let me run that first. Oops, wrong. Okay, this should be. We just fix the formula here, and the T should be here. Script. Okay, so this one, class. So let's change our formula. F2, function F2. Not here, here. Function F2. So it's the square root of the matrix var covar, and then should have the transpose. Okay, 1, 2, 3, 4. M mult. One, 2, 3. 1. Close this. Okay. Control Shift Enter. Okay, there you go. So this is our risk. Okay, in case you were having difficulty with the formula, let me share it with you. Control C. Okay, so that's the formula. And then make sure that you press Control Shift Enter. So this is very bad, class, very bad. My Excel is very bad. Taking so long. There. Okay, pause. I'll pause for a while, class. How are you getting along? Okay, thank you. Let's wait for the others to give their feedback. Bar cover option. Sige ha. Let me stop share. Sami, can you share your screen? Saan yung problem?
Oh, sir, like in the correlation, like
Correlation?
what's the formula kasi?
Ito yung formula ng correlation natin, di ba?
Yes.
Square root of your variance, covariance divided by the standard deviation. May I see, did you give a name to your variance, covariance? Could you highlight, please, M18 up to is that M17, highlight. Yung M17 up to O19. Paki-highlight. Paki-ano mo siya? Highlight mo.
Oh, this one.
Yan. Oo. Yan. Wala ka pang pangalan kasi.
Okay.
You have to give it a
Okay,
name.
okay, I get it now.
Oo. Dapat may, lagyan mo siya ng pangalan yun. Sige, gawin mong var covar.
Okay.
Okay? Yan, sige. Var covar. Yan, okay. Enter. There you go.
Got it, sir.
Okay na? Yan. Pero manual yan, ano? Sige, ano pa?
Oh, that's all lang naman. Because
Standard
also,
deviation nga, may see kung binigyan mo ng pangalan.
which one po?
Yung standard deviation. Yung
Oh,
ano ba yun? M7. Ayan, meron. May see that? Click mo yan. Yan, okay, tama. Okay, good. So, okay ka na sa bar cover. So, sa
yes.
baba, ano yung problema mo dun sa correlation? May see your formula there. Highlight mo nga yung M24 hanggang O26. Hindi, sa taas.
24.
M24, yung correlation mismo. Yung correlation matrix. There.
Okay.
Yung buo. F2 ka nga, F2. F2. Hindi mo linagyan ng array formula yan. Okay, i-share ko yung array formula. Pareho ba tayo ng ng cell positions?
Yes po.
Sige. I-share ko yung sige, I'll share again. Okay. Ito yung correlation natin, no? This one. Here. Okay. Lagay ko nga dito. Formula text. Ano? Isa lang. Okay. So this is the formula for the correlation. So you highlight M24 up to O26, and then you put this formula is equal to this one, and then Control Shift Enter. Every time you work with arrays, it should always be Control Shift Enter. Okay. All right. So we were able to compute for the expected returns for the risk of your portfolio. So we will now be able to compute for the Sharpe ratio. It's equal to expected return divided by the risk. Okay, and we're getting negative numbers because our expected returns is 0. Is negative, I mean. Okay, so may I know if you're done with this one? By the way, this is daily returns, right? Expected returns. If you want to compute for the annual returns, okay, so it's equal to 1 plus, since this is continuous, 1 plus the returns, okay, and then caret 252 trading days per year, 252. Very bad. Actually, it's very bad. 252 minus 1. Control Enter. Okay, so this is the annual returns. Negative. All right, so before I continue with the minimum variance class, kindly chat please if you're able to follow. Okay. Okay. Jishan, are you able to follow? Okay, good. All right. So what we're going to do now is, okay. By the way, I'll put the formula here. Okay, this is the formula there. All right, let's copy this. Let's copy this here. Control C and put it here. Control V. Let me check first. Huh? Yeah, we fixed the expected returns. Okay. All right, I'll copy this. Control C and then Control V. There. So the formulas are preserved. So what will happen is that we're going to ask Excel to compute for this one. Okay, what will be the weights if we want to have a portfolio where the risk is at a minimum? Okay, if we have equally weighted portfolio, what do you notice? If we have equally weighted portfolio, how does that compare with the standard deviation of Apple, of Google, and NVIDIA? Okay, the portfolio risk is 0.019, right? Here, the risk is 0.016, 0.02, 0.03. So it's a equally weighted class, and we were able to find a portfolio where the risk is less than that of Google and NVIDIA, except for Apple. Okay, so you can see here, by creating this portfolio, you at least have a risk that's less than Google and NVIDIA, but higher than Apple. Okay, for this one. But this is not the minimum variance portfolio. This is equally weighted. If you want minimum variance class, we will have to optimize this and ask Excel to solve this by solve for the weights by minimizing the standard deviation, the risk. Okay, so how do we do that? We go to data and then solver. Who among you have used solver before? Kindly chat, please, if you have used solver before. Optimization tool in Excel. Okay, next, used before. How about the others? Okay, yes. Okay, good. So all of you have used solver before? Okay. So let's now ask Excel to come up with a portfolio where the risk is minimized. So let's go to data and then solver. So this is the solver parameters. Okay, I'll reset all. Please reset all in case you have values there. Okay, kindly chat please if you were able to reach this far. If you have the solver parameter here. Hello class. I'll wait for you to access solver. About the others? Okay, sige. So before we use solver, okay, let me close this. Let's check first. Let's double check our formula. F2. Okay. Let's double check formula natin. M mult of M41, this is the weight and the transpose of the expected returns. It's okay. All right. Then this one, function. So it's the weight times variance covariance times the transfer of the weight. Okay, good. And this one is just division. All right. So let's now use solver, and then our objective will be to minimize risk, minimum variance. So for the set objective, we use this, okay, the risk, and then set objective to a minimum, okay, and then our changing cells will be our weights. This one, we're asking Excel to determine the weights that will give us the minimum risk. And for the constraint, let's add something here. We're going to impose, add, taking some time. Okay, add. Okay, we're going to impose that all the assets will be used. The weights should be equal to 1. So the weights here, weight 1 for Apple, weight 2 for Google, and weight 3 for NVIDIA should be equal to 100%. Okay. All right. Okay. Then we have here, you notice that this is clicked automatically, make unconstrained variables non-negative. Okay, which means that these are our weights and it should be non-negative. It will not allow zero values or negative values here. Okay, so this is your solver parameter. Okay, so I'll solve this. Let's solve it. Solve. And then here it says solver found a solution. Okay, all constraints and optimality conditions are satisfied, okay? So this is the solution. So it's telling us that if you want a portfolio that has the least amount of risk, then invest 66.4% in Apple, 28.8% in Google, and 4.7% in NVIDIA. Okay, it will give you a return of 0.07% daily return, or negative 17.195. Negative yung returns natin, no? And then the risk is 0.014. Okay, 0.014. So if you compare this with the with your assets, 0.014, you'll notice that your minimum variance portfolio is lower. Your risk is lower than any of the assets here. Okay, Apple has 0.016. Our portfolio has 0.014. Okay, so it's the if you're taking a look at risk, okay, no single asset will be able to match this because of because of the presence of the portfolio. Okay, so it's as if you have $1,000, you're invested $664 in Apple, $288 or pesos in Google, and 447 pesos in NVIDIA. Okay, so that's for your minimum variance. So how about creating a portfolio which maximizes returns? Control C. Control V. Okay, so same thing. Okay, same thing. We're going to ask Excel to create a portfolio. So go to Data, Solver, and then reset all so that we don't make any mistake. Reset all. And what we're going to, our objective will be our returns. This one, okay? We're going to maximize the Sharpe ratio, okay? Maximize it. Our changing cells are these weights, okay? And our constraint is that the sum should be equal to 1. There you go. Okay. Naghang na naman siya. Okay, solve. I'm sorry. Objective cell, what happened? Okay, what did I... Oh, sorry. 46. Nawala. Should be this one, right? Okay, 52. Maximum. 49 to 49, okay. All right. Solve. Albert found the solution. Okay. All right. Looks like pangit yung choices ng ano ko, no? Kasi yung returns natin, returns natin, pangit eh. Pangit siya. No? Kaya, anong nangyari? Lahat negative, oh. Okay. Let's copy this, ha? Copy lang natin to, ha? Copy natin dito. Okay. I'll make it 2. Subukan ko lang class, ha? 2. Kasi pangit yung, ano natin, yung, nag-random lang ako eh. If I change this with meta, let's see, meta kaya. Okay, everything changed, no? Everything changed. So dito meta to. Meta din to. May positive ba na returns? At least ito. At least may positive na returns. Kasi kanina wala eh. And maybe, subukan ko ha. Okay. I preserve class the, I preserve the original so that you can continue working on that. Ito, I'm going to replace this with Microsoft kaya. Microsoft. Okay. Okay. So nag-change siya. This should be now Microsoft. Hinanapan ko lang ng may positive na returns kasi lahat ng average returns natin ng negative. So let's see. Negative din si negative din si Microsoft. Dapat chinek ko na muna. Anyway, sige. At least positive si Meta class. So I'll revert to Apple na lang here. Apple. Apple. Okay. So let's just use this. Apple Meta. So for this one, this is Meta already. Meta. 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 Okay. So may positive na returns. This one are expected returns, negative pa rin. Tapos naglolo ko pa yung Excel ko. Ayan, positive na yun. Let's see here. Let me just rerun this. Check this class. We will have to rerun this equally weighted. No? And then ito, minimum variance. So I'm going to go to data, solver. Okay, reset all. I-recompute ko class yung minimum variance. So for minimum variance, this is our target cell. Objective is this one. Minimize. And then changing cells is this one. Okay. And then constraints add. This should be the sum should be equal to 100% there. Okay. All right. Okay. And then solve. Okay, let's see. Yeah, the solution change class. And the minimum risk is 0.014. Okay, 0.014. And if we compare that with the risk, the standard deviations of all the other assets there, 0.014 here, 0.016, 0.02, 0.0196, you can see that the risk of our portfolio is much lower than the individual assets. Although our Sharpe ratio, negative 0.025, okay, 0.025, it's lower than Google, but it's lower than Meta, okay? Meta, but we were not focusing on the returns here. We were focusing on the risk. Okay, so here, let's change this again also, class. Let's change this. Okay, so solver again, solver, and then our objective, reset all. Reset all. Our objective will be our Sharpe ratio, okay? And it should be maximized. And our changing cells is this one. And then let's add our constraint, the total, the sum of our weights. Okay, what happened to my solver? The sum of my weights here, it should be equal to 1. Okay. All right. Okay. Solver found a solution. Okay. All right. So unfortunately, we're told that we have to we have to put 100% of our weights in Meta, okay? Because it will give us the maximum return, 0.03. And if we compare this with this one, 0.03. So it's higher than the returns of Apple, higher than the returns of Google, but lower than Meta. Okay, lower than Meta. However, its risk 0.019 is between the risks of these assets. Apple has the lowest risk, 0.016, but our portfolio will always be in between the risk of all your assets. Okay, so let's do this, class. Let's maximize the Sharpe ratio, but this time let's put a constraint that at least the asset should have at least 10%, because here you're having Apple 0 and Meta 0. So let's copy this again, Control C, and then Control V. And then let's put here a constraint that the minimum weight, let's put here, or here, minimum weight. Minimum weight should be 10%. Okay? Minimum weight for all your assets should be 10%. Okay, so how do we do that? Once again, we go to Solver, and then reset all. No, actually, no need to reset all, class. Okay. Okay, cancel. Because all we need to do is the objective. Yeah, we have to change this. Sorry, we have to change this. This is now our returns, Sharpe ratio, maximize. Changing cells will now change. It will now be this one. Okay, and then the sum will still be 100%, but there's an additional constraint, add, and we have to impose that these ones, our weights, should be greater than or equal to 10%. Okay, all these weights should be greater than or equal to 10%. Not one of them should be less than 10%. Okay, all right. So we now have two constraints. The sum of the weights should be 100%, and this weight should be greater than 10%. Not one of them should be 0. Okay, all right, and then, okay, then solve. Oops, they do not converge. Okay, so we have a problem. I think okay, maybe okay, let's check. Maybe the constraint is, this is sum, okay. Maybe let's lower this. Let's make this 5%. Okay, so solver, same thing. We just change the minimum. This is M60, okay. All right, solve. Okay, it's not giving a solution. Why? Okay, anyway, so I will kindly help me check why it's not giving us a solution, class. But when because the solution here for the maximum Sharpe ratio returns Google and Apple to be 0. So you can impose that no asset should be 0. Okay, so that's why we're saying here that the minimum weight is 10%. So that should be okay. I don't know why. You see the formula. Yeah, the formula is okay. M7, yeah. Okay, let me see, class. What if I just make an incremental of 1%? The 10% should not be a problem, because 10%, 10%, then 80% would have gone to Meta. Yes, my question? My comment, class? Oh, but si Nix nagkaroon ng answer, no? Okay, how about in your case, class? So I was expecting that dapat 10, 10, and 80. Okay, let me check again my solver. How about in your case, class? Were you able to find a solution? Okay, let me get Solver. Yeah. Ano mali ko dito? Tama naman, M60, sharp ratio. Okay, maximize. Changing cells is M57 to O57. M57 to O57 should be greater than, okay, let me delete this, huh? And let me add, let's see. This should be okay. This should be greater than or equal to 0.10, although it's not good to put a constant there. It's best to put the value here. Okay. And then this one, the sum should be equal to 1. No problem with that. Okay, so what's wrong here? Solve objective cell values do not converge. Why? Okay. Anyway, in your case, class, did it converge? May I have your feedback? Kay Nix, nag-converge. For the others, class, what happened in your, as far as your solution is concerned? I will have to check. Maybe something's wrong with my. I've been having problems with my Excel this week pa. Okay, feedback please from the others. Were you able to get it? Just yes or no, please. Solver. Okay. May mali ba yung solver ko? Sige. Okay. Si Sammy nakuha, no? Ito yung solver ko. At tulungan niyo ako, baka may mali ako sa solver ko. M60 kasi, di ba? Sharp ratio. Okay? And then maximize. Changing cells ko, ito, M57 to O57. Tama. And then constraint ko, ginawa ko ng ano eh, finors, ano ko na eh.
Sir, the second constraint po should be P57, not P49.
I see. Okay. Paano naging P49 ako? Paano nag-move doon? Hindi ko chinek to, no? Okay, sorry
Yun po
about that.
yung sa previous na
Oo,
solver.
dapat ito siya eh. Dapat P57, but P49 pa rin. Pero I resetted. Hindi ako nag-reset ulit. Sige. Okay, let me close this first, okay? And then let me put the constraint here. So this is okay. So 10% dapat requirement ng person, dapat at least may 10% ang investment in any asset. So I'll go to solver again. Thank you, Nix. Hindi ko napansin yung ano, itong P59. So M60, okay, maximize. This is changing cells. Changing cells, let me change this and make it and peg it here. This is better because we can change this one, and then automatically when we rerun, it will solve. It will run. Okay, this one I'll have to change. It's not okay, dito sa kabila. No? Yun ang dahilan, class. Okay, P57 should be equal to 1. Okay, so this is okay now. All right, so solve, then I have a solution. Okay, may solution na yan. Okay, and it's 10. There we go, 10, 10. Okay, so the return is 0.02, 0.0218. We're maximizing. It's lower than 0.03. Okay, it's lower than 0.03 because we're imposing that there should be investment also in Apple and Google. Had we been very strict about this, then the solution would have been just Meta. Why? That's obvious, class. That's obvious because only Meta has positive average returns. The others are negative. So that's why it would have been better had I chosen stocks that had positive average returns. However, kanina kasi gumawa ako pero same assets pero hindi Nvidia and iba yung period kaya yun doon naging iba. All right, how about this class? Okay, we'll have to finish class up to number 7 because this is the efficient frontier. Okay, so let's copy this again. Okay, Control C, and then Control V. Okay, this time we will allow short sales. When you say short sales class, it means that you allow negative weights, which means what happens with negative weights is that you borrow first, and then you sell that asset, and then you buy another asset, okay, and then later on you sell, and then you buy again the asset that you bought, and then return it because you're just borrowing. Philippine laws does not allow yet, no, short sales, but I think there's a move to allow it. Okay, so how do we solve this now? Solver again, solver, and then we're going to remove this constraint, delete this. Wait, reset all. Again, I might make a mistake. I think I said that a while ago, reset all so that you don't make a mistake, which I did not do, okay? That's why I made a mistake. Set objective is maximize Sharpe ratio here, okay? Maximize, changing cells. We're now here. Changing cells, this one, okay? And then add constraints. Our constraint is still 100%. Where's my constraint? Where's my, what happened to my solver? Constraint is, this is 100, equal to 100%. Okay, equal to 1. However, class, however, okay, since we're allowing for short sales, we can just click this. Okay, make unconstrained variables non-negative. We can unclick that, okay, which means that we can allow negative numbers here, negative weights. Okay, solve. Okay, does not converge. Again, I might have made a mistake. How about in your case? Did you have a solution? Or it's also possible that it did not converge. So it was not allowing negative values here. Kasi, class, yeah, I think we cannot do that kasi may mga, that's a problem because we have negative returns. No? So that's the problem, class. If you have negative average returns, it will sometimes skew the solution. So I think that's the reason why we're not having this one. Okay.
Wow. I
All
told
right,
you I'm
so
available
I'll
after
I'll leave that class,
practice then.
and then so I leave this to you, class, as an exercise. So what you do is with risk less than the least risky asset. Okay, so you're maximizing Sharpe ratio. However, you would want that the standard deviation of your portfolio be it should be, okay, what, less than or equal to, what's the least here? 0.0164. So it should be less than, the risk should be less than this one. Okay, I think we have time to do it, guys. Let's just do it to complete your, okay. Apologies, class, for a little bit of an extension. Okay, so copy this one, Control C, and then Control V. Okay, I'll copy it here, class. So let me start first with the last one here. Here, Control V. All right, copy it here. Let me start with number 7 because this is the most important one. So the weights here, what we're going to do with the weights, I'm going to put the stocks here, okay? And then I'm going to use random weights. Okay, random weights. How am I going to generate random weights? I'm going to use random arrays. I hope you're following, class. And for random arrays, I'm going to use the function rand array is equal to rand array there. Okay, how many rows? 1 row. How many columns? 3 columns. Okay, I'm generating random numbers for Apple, Google, and Meta. Three columns, one row. Enter, class. Okay. So you can see if I press F9, okay, still running. Okay, F9 function, F9 on my part. You can see that. Okay, it's changing, right? So if I get the sum of this out equal to enter, okay. So function F9 in my case or F9 in your case, okay, you can see that the random numbers, which numbers from 1 to 0 to 1 are changing, it's changing, and the sum is changing. So that the weights will always be equal to 100%. What we do is to get this one, the weight of Apple divided by the total. And then I'm going to fix this function F4. That way, you're always dividing it with the total. Control Enter. All right. So this one, okay, as you can see now, the sum will always be 100%. And if I press function F9, okay, the random arrays are changing, but the combinations of your random weights will always be 100%. Okay, may I have your confirmation, class, please, if you were able to get the random weights, because that's very important, because we're now going to generate our efficient frontier. Can I please see your, okay, random weights? Okay, sige. All right. So this is the setup, okay? You have our assets here. Okay, so let me delete this. Okay. So I'm going to first generate random arrays. Rand arrays there. Rand array. Okay. So it requires that our rows be identified. How many rows? One row only. How many columns? 3. I'm not setting a minimum and a maximum nor an integer requirement. Okay. The default will be it will give numbers from 0 to 1. Okay. Control Enter. Okay. So there, it generated random numbers, okay, for Apple, for Google, and Meta. So I added them, and if you run the random number generator there, F9 recalculate, okay, you notice that the sum changes. The sum will change. Can you hear me, class? Ay, ba't nawala yung sound ko? Okay. All right, then our random weights, to let it be equal to 1, we divide your random array with the total and then fix the total, function F4. Okay, so that the divisor will always be the total, so that you generate numbers, percentages, actually, proportions, and then you, okay. All right. So now we can generate different random weights, and then it will now give different risk and returns. Okay, this is our return. This is our risk. Okay, so let's do that. Let's now create, okay, let's generate, let's say, okay, 10,000 portfolios. We can do that. Okay, very easy. Okay, I'll go here. Okay, here, class. So let's generate one up to 10,000 here. So we go to editing here, class, home, and then here, class, fill series, okay, columns. I'd like to generate numbers in columns from 1 up to 10,000. 10, 1, 2, 3. So it should be in columns, class. Okay. So this will generate, I'm sorry, I have to start with the number 1. 1, okay. And then again, go here, series, Okay. Step value is 1, which means 1 each, up to 10,000. Okay. Oops. Sorry. I forgot. Oh no. Control Shift. Forgot to click the column. Okay, good. Here, once again, series, columns, okay? Make sure you press column because otherwise it will do row wise. Step value increments of 1 up to 10,000. Okay. All right, there you go. So we have 10,000 numbers here. And then our our risk will be here. So let's go here to our random weights. We will link our risk to this one. This is our risk, right? Okay, and it's linked to our random weights. Okay, enter. And then we also link our returns, our expected returns is equal to. We also link it here. Here class here. There, okay? That's our returns, expected returns. Control enter. Okay. Here is our risk. Here is our return. So what we're going to do is we're going to ask Excel, okay, to generate 10,000 values of risk and returns. Okay, 10,000, which means it will iterate the random weights. Okay, it will iterate the random array, and then it will, based on the random array, it will generate weights, and then it will compute the risk and return based on those weights. Okay, so how do you do that? Okay, we highlight this one. Make sure that this one should be, okay, it should link to your risk and return. Okay, and then Control Shift down arrow. Okay, highlight that class, highlight that. Okay, and then you go to, okay, let me pause for a while. Are you with me now, class? Because this is the last step. Can you chat, please, if you're following? Okay, good. All right, good. Thank you. All right, so let me highlight this again. And then you go to data. Okay, and then you have here your sensitivity analysis, what if analysis, and then data table here. Multiple inputs at the same time. Okay, click this. And then we're not going to input in the row. What we're going to input are columns. Column for risk and column for return. So you just click here, column input cell, and then click anywhere here. Your column input cell will be, say, here, okay? Anywhere outside your data table. Okay, I place it here in V2. You can place it, but not inside your data table, okay? All right, then, okay. Okay, there you go, class. 10,000 instances of risk and returns. Okay, 10,000 all in all. Okay. Kindly chat, please, if you were able to get it. And any comment, class? What do you think about it? Is it something that's an aha? That's good. No reaction. Imagine if you're going to create 10,000 portfolios. Of course, you can make 100,000 How about the others, class? I'm not seeing any comment from the others. Yeah, oo, 'di ba? Napaka ano ng Excel, no? Ang dami pang pwedeng actually very powerful. Okay, so we're now ready to highlight natin to, class. Control C. And then let's now create our efficient frontier. I-plot natin, class, yung mga risk and returns natin. Insert. And then charts, this one. Let's choose this one. Okay, there. Oh, this is now your efficient frontier. Okay. Sige, tingnan natin, ha. Okay, let's improve this a bit, no? Okay. May mga negative tayo, no? Kasi negative yung ano natin, eh. Kanina I did this, yung average returns, positive lot, kaya lot sila nasa upper, no? But let's just fix this a bit. Right-click natin, tapos i-format natin yung data series natin. Here, sa fill, yung marker, baguhin natin, no? Yung marker natin, here, marker options. Let's make the marker options, yung ano lang, maliit lang na ano, here. Okay. Ayun na naman. Please cooperate. We're ending. Ulitin ko. Click there. Format data series. Ito. Marker. Marker yan kasi. Okay, and the marker I want is sorry, hindi ko ba. I forgot to click built-in. Ay, nako. Built-in. Sorry, class. Paki-click si built-in. Ayan na naman. Nag-ano na naman siya. Built-in. Yung ano lang, ito lang, yung mga X lang, yung X lang na yan, no? And then let's make it the smallest possible. 1 lang. Yan. Okay, medyo nag-improve siya. Tapos, okay. Tapos let's put the lowest value here. Kasi ano ba to? 0.01. So this is around, ano ba to? Gawin natin 0.013, no? 0.013. Kasi ito 0.01. Yung pinaka-minimum dito 0.01, mga 0.014, no? So let's format the axis and make it the axis option, yung minimum natin 0.013. Okay, enter. There, class there. Looks good. Looks good. So this is now your efficient frontier. There. Okay, so you should understand, class, in your paper, you should explain what this efficient frontier is, and then you should try to identify, there is a way to identify exact sample. These are all portfolios, class. And the efficient frontier tells us that, okay, these are the best. Okay, let's see. May mga negative kasi dito, no? Kaya actually, class, what happens now is that your efficient frontier, okay, kasi negative returns na to, so parang limited na hanggang dito, class, no? Okay, of course, you don't want to have a portfolio where the returns are negative. Okay, so this constrains us to have this one. So as far as this one, class, as far as this one is concerned, okay, this one, this is really your efficient frontier line. Okay, why is that so? So this, for example, this one, this portfolio here, if you compare it with this portfolio here, okay, same level of risk. This is your risk class. This is your sigma. Same level of risk, but the returns of portfolio, this is, let's call this portfolio A. the returns of portfolio A is higher than the returns of portfolio B, given the same level of risk. Okay, so those assets that are located here, except for this one class, here the returns are already negative. So this is not part of the quote unquote efficient frontier. Okay, because here class, your returns are negative. Although, for example, at this point, okay, the returns may be negative here. Okay, this one also, you have the same risk. Okay, but technically class, the returns are quote unquote higher because they're less negative between these two assets. Okay. All right. Any questions, class? How was it, class, today? Did you learn something today? I'm sorry I had to extend because I wanted to finish this. Did you learn something today? Yes, thank you. Okay, thank you, Jason. How about the others? I just want to hear some feedback from you. Okay, good. Take time to review it, class. Take time to experiment. Okay, in your case, you have to submit this class for next Saturday, and then I'll announce the next case, because at least we'll have to have, I don't know if we'll still have an opportunity to have a face-to-face exams, maybe two shorter cases after this case one. Okay, thank you so much, class. I'll stop recording now.